All right, today's calculus lecture is, we'll call it lecture 5.4a. In the book, we're going to be on page 344. And it's called Derivatives of Exponential Functions. So if we have f of x is equal to e to the x, the derivative of that is really easy. F prime of x is just e to the x. Okay, the reason for that I can show is because of the graph of y equals e to the x. If we were to graph that, and we did this on the first lecture of this chapter, we know that the slope of the tangent line at x equals 0 is equal to 1. The derivative is just a slope. So f prime of x is just going to be the same thing, e to the x. So the number e appears in mathematical equations whenever things are growing. So if you have a large population, you will have very fast growth. You can see that as you go down the x-axis, how it gets steeper and steeper. So the function is growing faster. If you have a small population, you have very slow growth. Okay, so you can see as you go to the left on this function that the raise of the curve is at a much slower rate. All right, so we're going to, in order to help us do the calculus, we might need to rewrite some equations. Okay, so just a few of problems where we're changing from natural log to e or vice versa to make the calculus a little easier. So our first example is example 2 on page 344. And the instructions are, if it's e, change it to natural log. If it's natural log, change it to e, or an exponential equation. So our first one is e to the minus 2 is equal to 0.1353. All right, so what you can do there is take the natural log of both sides, then we can bring this negative 2 as a coefficient out front. Natural log of e is 1, so you'd have negative 2 is equal to the natural log of 0.1353. All right, so you can check that in your calculator. All right. Our next example is number 4, where we have the natural log of 0.5 is equal to negative 0.6931. Okay, what you can do there is exponentiate both sides. So that means write a base of e and raise e to the natural log of 0.5 power is equal to e to the minus 0.6931 power. That is the same thing. We're not doing anything mathematically incorrect, because if you have the same base, you can set the exponents equal to each other. All right, so now e and natural log cancel out. So we have 0.5 is equal to e to the minus 0.6931. So I want to remind you of something from pre-cal, and that is, you're going to want to memorize this. E to the natural log of A is just equal to A. Okay, so that's what we were doing here. Okay, E to the natural log of A, the E and the natural log cancel each other out. All right, and you can check in your calculator and see if that one is true. All right, example 6. Okay, it says we have e to the natural log of 2x is equal to 12. We want to solve for x. Well, e and natural log cancel each other out. So we have 2x is equal to 12. So x is equal to 6. All right, the next example, the last one before we start doing the calculus, example 8. All right, so that is natural log of x squared is equal to 10. Okay, so what we want to do is exponentiate both sides. We want to solve for x. So e to the natural log of x squared is equal to e to the 10th. E and natural log cancel each other out. You have x squared is equal to e to the 10th. Take the square root of both sides. X is equal to the square root of e to the 10th. So x is equal to e to the 5th, but be careful, it's going to be plus or minus e to the 5th. Okay, so sometimes we have to use these mathematical tools to rewrite to make the calculus easier to do, to make taking derivatives easier or integrating easier. All right, so let's do a few examples where we take derivatives. The first one is example 30 on page 345. So in this one we have f of x is equal to e to the 1 minus x. All right, so f prime of x, the way you do it, is equal to e to the 1 minus x times the derivative of the blop. The blop in this case is just the exponent. The derivative of 1 minus x would be negative 1. So that's negative e to the 1 minus x. All right, our next example, number 34. We have y is equal to x squared times e to the minus x. This is going to be a product rule. So y prime will be the first, x squared, times the derivative of the second, that's e to the minus x, times the derivative of negative x, so times negative 1, plus the second, e to the minus x, times the derivative of x squared, so that's times 2x. We'll clean that up. That'd be negative x squared e to the minus x plus 2x e to the minus x. I am fine with you leaving it like that. The book might factor out an x and an e to the minus x, but that's just as simple. So I'm perfectly fine with you leaving it that way. All right, our next example is number 40. Here we have y is equal to the natural log of e to the x plus e to the minus x over 2. Well, it's going to be a lot easier to take the derivative of this if we can rewrite this as a difference instead of a fraction. So let's rewrite it as y is equal to the natural log of e to the x plus e to the minus x minus the natural log of 2. The natural log of 2 is just a number, so when you take the derivative of it, it'll be 0. So y prime is going to be 1 over e to the x plus e to the minus x times the derivative of the blob. Well, that's going to be e to the x, and the derivative of e to the minus x would be minus e to the minus x. So putting that fraction together, you'd have e to the x minus e to the minus x over e to the x plus e to the minus x. All right, I've got 2 more examples. Example 46, we have y is equal to e cubed times the natural log of x. E cubed is just a number like 2 or 3 or 4. So if you were taking the derivative of 4 times the natural log of x, it would just be 4 over x. Okay, so just think of e cubed, it's just a number. Don't worry about it having an e in it. So y prime would be e cubed over x. Another way to think of it is the first, e cubed, times the derivative of the second, 1 over x, plus the second natural log of x times the derivative of the first, which is 0. And that would still give you e cubed over x. Our last example is 48. We have y is equal to the natural log of e to the x. Okay, so what you can do is rewrite this. We can bring that x out front as a coefficient. X times the natural log of e. The natural log of e is just 1. So y is equal to x, and y prime would then just be 1. All right, so your homework for this section . Okay, so we're on page 344. Be 1 through 7 odd. 29 through 47 odd, and number 66.